Hello, welcome to Tech Dicted. Today we are looking at the PN junction. And the PN junction, we are basically talking about diodes. So this is a diode. Let me just take a pen. So a diode is a PN junction. Last time we talked about transistors, and a transistor is a PNP junction or NPN, okay? So at the center of it is a PN junction. So when we talk about the PN junction, this is PN, okay? This is an example of a diode, which I will show you in a little while. And this is the symbol for the diode. Depending on which diode, you may have arrows pointing out or pointing in, depending on whether they are emitting light or getting light from a different place. Yeah, so we will talk about that too. So this is an example of a diode. This is a general purpose diode, and the IN4007, and today we are going to use it as a way of, let's say, limiting current from flowing in a different direction. A diode basically allows current to flow only in one direction. Basically how the symbol just looks like, current only flows in this direction and it cannot flow back, okay? And this is now the P region. We call it P because it has holes, and N because it has electrons. And then this space between is called the depletion region, whereby when it's unbiased, this is an unbiased one, meaning it's not connected to any battery source. When it's unbiased, the electrons and the holes that are at the conduction band, okay, there is something called the conduction band. So when we have electrons, okay, at the conduction band, they combine with the holes, okay, that are also close, and therefore when they combine, they form this, a region where none of this can pass through, because when they try passing through, they're blocked by this, and when this one's try going through this other direction, blocked by this, and also they don't have enough energy to pass through because they're not biased. It's just like that. Now they can either be biased forward or backward. Okay, so we have forward bias, whereby we connect the battery such a way that the negative is connected to the negative side, okay? That's the P. The N region is connected to the negative side, and the P region is connected to the positive side. So this and this are not attracted to each other, so they are repelled, okay? And then it's attracted to this side, so it comes through. Okay, so then there is that combination, and there is flow of, when there is when this happens, okay, these ones are being attracted this way and these ones are being attracted this way, then there is current flow, and therefore it shows this connection has been done this way, okay, forward bias. So using a battery, then our diode is able to conduct current in this direction. However, if we place I forgot to mention something. When they are, when they are forward biased, that means also this is very small. Why is it small? Basically, we said the energy that this unbiased one is capable of handling is just the ones that are at the conduction band. They just meet and then they create this space charge or depletion layer. However, when you energize this circuit using a battery, okay, then current, there is a voltage that is able to push through, and when we cross the 0.7 volts, for a diode we need 0.7 volts and above for it to start conducting. When it's below that, the energy is still not enough for this ones to be pushed towards this direction and this one to be pushed towards this direction. So you need the energy, the voltage, to be above 0.7, okay, in the real world setting. 0.7 volts and above will be able to allow current to flow through this circuit. Now, when we reverse bias, that means, let me just remove these ones from here so that we don't have a lot going on. When we reverse bias, that means the N region is connected to the positive, P is connected to the negative, and that means the electrons will be attracted to this side, and the other ones, what are they? The holes will be attracted to this side because the relationship, this negative charges attract the positive ones and vice versa. And therefore the depletion layer will be wider. And remember, the depletion layer is a space charged region, meaning we have this kind of condition. This will be valid when we're talking about photodiodes. Okay, so when the diode is connected in this kind of way, then the current cannot be conducted. There is no current flowing in this circuit. Okay, it just remains, it's like an open circuit. Yeah, it's like an open circuit. This acts as an open circuit, and therefore when we connect this diode, okay, when we connect this diode in our circuit and we connect it reverse biased, in a reverse biased manner, then there will be no current flowing through that direction. So if you don't want current to flow using a certain path, you can use a diode to limit it, as long as the current and the voltage rating does not exceed what this diode can handle. Okay, so with that in mind, let's talk about the characteristics of a diode. Okay, so we've said there is a certain voltage where you must get to so that current can start flowing through our diode, and that's the 0.7 volts for silicon, okay, and 0.3 for germanium. Preferably we use the silicon one, so it's 0.7 volts. So we need at least 0.7 volts for current to start flowing in the forward biased state. And then when we connect it in reverse bias, it will be able to not conduct, right? But the problem will be that it reaches to a certain point where it can no longer resist, and then it will start conducting. Okay, so when you go past a certain limit, okay, when you've connected it in a reverse biased way, there is a rating such that when you pass this limit, it will start conducting. Mostly we have diodes which function that way. Those are called Zener diodes, and this region is called Zener diode or avalanche region. Yes, Zener breakdown or avalanche region. Okay, where there is conduction in the opposite direction. Okay. Yes, so that's it. We've shown you the current is flowing in this way. It's exactly the way this thing is pointing. This is the negative side and the positive side. Okay, current is flowing from positive to negative. I also mentioned we need 0.7 volts for it to be closed, and if it's below 0.7, it will be open. Don't know if you can see that. Okay, so we have the 0.7 volts. We have 0.7 to be closed, 0.7 to be open. Okay, ideally it would have been it's open or closed. It's open when you're flowing this way, closed when you're flowing the other way. When it's forward biased, it's a closed circuit. When it's reverse biased, it's an open circuit. But it does not work that way because of this 0.7 volts that we require. This is 0.7 volts. Okay, so it's not direct that it's open or closed. We also have that 0.7 that should be considered for it to be opened or closed. Okay, yeah, so we're going to look at this simple circuit. I actually made it, and then we're going to examine it. So we have a diode. We have two diodes here. This is a light emitting diode, and this is a general purpose diode. In this case, it will allow current to flow in this direction. However, if we reverse it, no current will be able to flow. And since this is also a diode, it also allows current to flow in this direction. If we reverse the polarity, if we reverse it, there will be no current flow. So we're going to examine this circuit. This needs 0.7 volts to be on. Okay, it's also in the data sheet, but it needs 0.7 volts to be on. This needs Oh, it can take up to 300 milliamperes, so we're good because this only requires 20 milliamperes. This only requires 20 milliamperes, and it requires a voltage of 2 volts. So that means if we are supplying it with 5 volts, we will need this resistor to be 5 minus 2.7, okay? 2.7 volts, this is 5 volts, divide by, we're finding the resistance. V is equals to I, R. Therefore, R is equals to V over I. So, to find the resistance, we say 5 minus 2.7, 2.7 meaning the already existing voltage. So we want to, we're looking for this voltage here. It's 5 minus 2.7. It's a closed loop. So the voltage being consumed should be equal to the voltage at the source. That's why we're saying 5 minus 2.7 to find the voltage required for this part, or for the resistor. And then we divide by the current we want to pass through this circuit. And the current we want passing through this circuit is 20 milliamperes. And therefore, we divide it by 20 milliamperes, and we find our resistance as, 5 minus 2.7 divided by 20 exponential negative 3, because 20 milliamperes is 20 times 10 power negative 3. So it's 115. We need 115 ohms. However, since we do not have a 115 ohm resistor, we will just go with the 100 ohm resistor. Yeah, so we're going to use 100 milliamperes. Therefore, now let's look at the circuit. This is the circuit. It's quite simple. We have our LED, which is a light emitting diode. We have our diode. I don't know if it can be seen. We have our diode. This is a diode. Okay. And we have our resistor, 100 ohms. And then this is just a switch. So we're going to look at this circuit. First of all, let's just connect it to power. Okay. And then when we click it, it's on, it's off, it's on, it's off. If we reverse, we said it cannot work when it's reversed. Positive to negative. I think this is, if it's reversed, it does not work. Okay. And since the voltage has not passed its reverse voltage, then it will not blow up. I'm sorry, I've still connected it wrong. Positive to negative. Oh, the positive is the long leg, the negative is the short one. Positive is the long leg, negative the short one. Let me connect it back. It's working. Now let's reverse this. How do you know this one? Okay, so in my drawing, I forgot to mention one thing. Let me search for it. See this thing? Okay, this indicates this is the negative. This is the negative in the symbol, and this is the negative in the actual diode. Okay, so in this diode, we have that gray thing at the end there. Don't know if you can see it, the gray thing at this end, and so that's the negative. And so this way it's flowing right, and then if we reverse it, no current is I'm pressing the wrong thing. No current is flowing. Let's now take it back. And now there's current flow. Okay, so let's measure the voltages and all that. Let's confirm that this circuit is exactly this circuit. So we take our multimeter, go to voltage, does not exceed 20, so we'll place it there. Let's look at the voltage at the diode. So first let's make it on throughout, because right now it will measure 0 because there's no voltage. it's the thing is off. Okay, so let's just make it stay on, and then let's put this here and put this here. So we have 0.73. That's fine. 0.7, that's fine. Then let's look at the voltage at this part. We have 2.1. That's okay. 2.1 is okay. And let's look at the voltage flowing through the resistor. It's 2 volts. And therefore, if it's 2 volts, we said 5 minus 2.7. So that's okay. 2.3, that's fine. And then let's check the 20 milliamperes. Does the current run on that? We can just remove this now, because this was completing the circuit such that we don't have to keep on closing, opening. So let's go to the milliamperes. Okay, remove this and now complete the circuit with this, and it's 19, 18, 19.4. So 19.4 is a good number. It's 19.4. This is 20 milliamperes, so we are doing well. And that's it for today. We have worked with the diode. Okay, this is the symbol for the light emitting diode. Okay, it has arrows pointing out, and we have the negative and we have the positive leg. Okay, positive is always the longer leg. That's it for today. Let me see you in the next one. Thank you.